Severe weather events, like storms, floods, and heat waves, pose serious risks to our communities, environment, and economies. In a world in which our changing climate is increasing the risk from hazardous weather, we need to bridge the gap to protect ourselves. Thankfully, science has made great strides in understanding, monitoring, and predicting severe weather. Sophisticated tools and services help us stay informed. But even with all this progress, major disasters highlight the gap between what we know and how we use that knowledge. We need to bridge that gap to protect ourselves and our planet. What is the High Impact Weather Project? The High Impact Weather Project aimed to make us better prepared for extreme weather events worldwide. How? By improving our understanding, by developing more accurate and informative forecasts, and by researching ways to make sure that information enables effective action. The project was a 10-year effort to enhance our ability to handle weather challenges, finishing in 2024. The project focused on 4 key areas: advancing and documenting capability. The Nordex Field Programme and engagement with field projects in South America and East Asia has fed into HIWeather-linked research in the German Waves to Weather project that has greatly advanced our understanding of the sources of hazardous weather. HIWeather scientists have been involved in advancing prediction capabilities, especially in the areas of convection, permitting modelling, coupled modelling, and impact prediction. Aspects of the communication of information in warnings have been the subject of new research in HIWeather. Bringing together these distinct yet complementary areas of science into a coherent value chain framework for creating and communicating warnings. HIWeather produced a book which both describes good practice across these areas and promotes the need for interdisciplinary partnerships that connect them together. The freely downloadable book is for professionals, meteorologists, emergency managers, risk reducers, but also for curious minds. It is about making weather warnings more effective in saving lives, property, livelihoods, and infrastructure. The warning process is described as a pathway linking each step along the value chain. 5 bridges represent the communication, translation, and interpretation of information as it passes over the divide from one area of expertise to another. The required partnerships are described, including the expertise that each partner brings, the challenges of communication between them, and the structures and methods of working that build effective partnerships. Starting with the decision maker, the book chapters move along the value chain and over the bridges, emphasizing the importance of co-design and co-production in the warning process. The book was written by 49 co-authors from around the world as part of the High Impact Weather Project. It has been published by Springer. You can download it from the link in the comments below. Characterizing and evaluating the weather warning process. Imagine a world where weather warnings are reliable, timely, and effective. It's not just about predicting storms or floods, it's about connecting the dots across a network of experts, communicators, and decision makers. The Warning Value Chain project ran from 2021-2024. It investigated how information flows from observing what is happening in the atmosphere to modelling and forecasting the hazards and impacts, right through to communicating and acting on the information. The Warning Value Chain project looked at how we can evaluate each step in that process to identify any weak links. The project developed templates for any weather services, emergency managers, and researchers to use to record what happened after a high-impact weather event. A database is also in development to help researchers investigate those weak links in future So next time you see a weather warning, remember, it's not just a forecast, it's a symphony of collaboration, keeping us one step ahead of the storm. Establishing the path for including citizen science in weather forecasts. The Citizen Science Project brought together a series of activities from around the world to showcase how members of the public can contribute to advancing our knowledge about high-impact weather. An example is how the Ghana Meteorological Agency is collecting observations about the weather from the public using WhatsApp. These important contributions have helped them to evaluate and improve their forecasts. Another example is how citizens all around China have collected hailstones to help researchers from Peking University. People pick up the hailstones carefully, store them in their freezer, and record where and when they were collected. The researchers travel to collect the hailstones and conduct scientific experiments on them to advance their understanding of the chemical composition of the hail. This then feeds into better forecasting of hail in future to help their impacts be reduced. 2 World Meteorological Organization guidance notes were produced by the High Impact Weather Project team members. The first was written to guide project leaders to raise key questions as they start their own citizen science projects. The second, Citizen Science Guidance Note, provides tools and insights for groups and agencies who are embarking on crowdsourcing weather projects. Citizen science has a significant role in bridging knowledge gaps. The High Impact Weather Project has paved the way forward to help have meaningful engagement with diverse communities, whilst harnessing the power of the crowd to gather essential weather data. Exploring impact-based forecasts and warnings. One way to provide more meaningful weather warnings is to trigger them based on the level of expected impact, such as what the damage might be rather than on the forecasted hazard, such as predicted wind speed. Called impact-based warnings, there was little known about whether they were actually more effective at helping people respond. The High Impact Weather Project investigated the availability of data underpinning impact-based warnings and found a need for strong interagency partnerships. An international workshop series identified several key challenges that agencies face when developing impact-based warning systems and some solutions. Overall, the project found that a cautious approach should be taken when moving towards an impact-based weather warning system. Research directions have been identified by the High Impact Weather Project to help fill these knowledge gaps. Across continents and time zones, the High Impact Weather Project has driven important research to help advance the mitigation of severe weather events. It has demonstrated the value of interdisciplinary research that is connected to practice. It leaves the legacy of tools, templates, a database, and publications and directions for future research. The project has built a strengthened global network of researchers so we can continue to learn from one another. It has also helped to grow tomorrow's scientific leaders. Through the work of the High Impact Weather Project, we are closer to bridging the gap between advanced scientific knowledge and its application. Together, we are reducing the impacts of future severe weather events